in Revit, mainly because they're typically unusually complex for as simple as they are. Um, Railings are typically a drawn line. Um, we're kind of going to go over pieces of a railing because it can be kind of complex to kind of talk real in depth about it. So we're just a very basic overview of what they are. And so typically they consist of a top rail and or a handrail. We'll go over what those mean specifically. Balusters, there's a button called rail structure, which we'll talk about how we structure that. And then they consist of end and corner posts. Um, and this is for Elliot, the third rail thing. So we're going to touch the thing that we don't want to touch. Um,
What do you mean? I love having third rail.
you do. Um, so railings are system families, but they consist of nested components that are separate families. So you have to construct it as a system family, and those things can be hosted to stair stringers, to landings, to sites, to walls. And it's important that we understand like what we're hosting it to. Like you can tell that there's the handrail that's going to be wall mounted off of that, and there's no guardrail attached to that. Then there's the guardrail, which has a handrail attached to it that's attached to the stringer. And then there's the landing rail, which is just going to be off the landing. So railings are great because they can take a slope, so it can fit the slope of the railing, or we can actually define the slope separately if it's like a floating rail or something like that. So it's really great because it is just, you know, in its simplest idea, it's just a, you know, from ground to handrail height, it's just a continuous line. And then if you change the grade, it's going to change with it. So just trying to get everyone on that same understanding of what a railing is. And so to jump into how a rail is structured, when you click on a rail in Revit and then you click on the edit type button, you get this pop up here, which is this whole type properties of the railing. And the first button is really the rail structure. And for this one in Everly, you have two rails. You have the bottom rail and the top rail. Um, that is separate from what they refer to as the top rail. So to let you know that there's a top rail, and then we are defining this as like that's what we call the top rail. You can name this whatever you want, um, just to help you understand, and I'll show you another example of that. But this is giving me the understanding of what I want the balusters to go to. Um, so it's setting my height, it's setting my bottom rail height, and you notice that it's a ½ inch, and it's probably because these are based off profiles, and that profile might have been an inch under the origin, and we just want to push it up above the origin to make sure that it's hitting right on top of the stringer versus like in the stringer. So there's a lot of like understanding of where the origin is and how you place the part of the rail to make sure that it's displaying properly. Um, I said that they're based off of profiles, so all this is just like a shape, and then it's an extruded shape as long as the railing goes. And then the material is something that we can control the whole railing material throughout. So if we wanted to say that the all of this was going to be an urbane bronze uh, wood rail and painted, then we can set the material here, and then like all of our railings are painted that color. So from rail structure, you can get into baluster structure, baluster placement. And again, this is the vertical elements within the rail. And the thing to remember here is that it's this is a railing family that was a baluster. So I'm selecting the baluster family, which is the square 3/4 inch one. We can build these to be parametric to make all bunch of different sizes. So if we have a generic square shape, we can say we have a 3/4 inch, a 2 inch, a 5 inch, like whatever your fancy is, that we can set the different sizes and then make the pattern out of them. So the things to look at here is you have your base and your top. Um, those are important to remember of like if we want to have a toe kick that's got a 2 inch and then there's a rail and then we have balusters slats that go across like that, we would want to make sure that the bottom, the base is the bottom rail. So that way we can make sure that the balusters don't go below that bottom rail. And the top rail is obviously we don't want balusters to go above the top rail. The top rail is the cap. of that. And so these are drop-down selections within Revit. So when I showed you before, when I like named that top rail and bottom rail, I could name this like Everly 4A1 top rail, and it would come up in this one. The ability to show the where you're wanting to hit it. So that's that top and this bottom are looking at the rail structure. And then we'll get into this a little bit more, but the distance from previous, this is the spacing that you're giving it. So if you want, make sure that you're giving it a 4-inch opening, or if you want it to be a tighter opening, you can set this here. And a lot of this is a figuring out what the spacing is, and then you have to do some math to figure out like what that actually is, and we'll kind of get into that. Down here at the in between the two tables, you have the break the pattern. This is kind of when this gets bigger into when you have panels, but when does the pattern break? So it's kind of confusing because when you get into at the segment end, you can justify it to fit, or you can fill the excess length of what you're going to do. Because sometimes based upon the rail, you're kind of having to figure out like there's an extra piece, there's an extra 6 inches, and what do we fill it with? So we'll get into like how we calculate those railings in a little bit. And then at the end, there's the balusters that are the end and the corner posts, and we'll get into this one in a second. So I'll go jump ahead. This is a great example of an end post. So we have the tapered end columns or end posts, and that is a baluster that's set up as the end post. And I have this named the chamfered top because obviously it has a chamfered top. We want to make sure that we name things properly so that way when we're changing them, we understand how they're being used. And so for this situation, we have a baluster end post chamfered left and a balustered end post chamfered right, because you can't rotate the family in within the options within the rail structure. So I have to make a left and a right. And so that allows us to create the symmetry that we're looking at. And this beautiful railing has only two main balusters in it, and those are the things that are hitting in the middle. So that's why the justification is at the center. We want to make sure that it's justified, and the rail is in the middle, or the balusters in the middle. And then you can see here that the base offset is making sure that we're down at the host, and then it goes up to the top. So we're just allowing it to go from bottom to top. And then the baluster end post have an extension at the top that I can control within their parameters. So does anyone have any questions? I know that I'm kind of talking about balusters and rails, but we're good?
You hear me? What was the thing you're saying that you can't rotate? So you have to create two. Is that just around the corner, or is that because it has a chamfer on it?
Yeah, that's a great question. It is because it's an asymmetrical baluster. So I like the way that was drawn, it's like angling one way. If it's um, I have another one, what's a pyramid cap, it doesn't matter. If you have a corner post that's a pyramid, then it doesn't have to have a left and a right. But in this case, and I have another one where we talk about a left and a right. Um, but to create the looks of things that are symmetrical, or the chevrons like meet in the middle, you have to create a left and a right to be able to control those patterns properly. But yeah, you can't rotate the end posts. So like if you wanted to have a directionality to the end post, we would need to make a family that can do that. So just to keep that in mind, these were we reuse these a bunch. It's just I've made them to be pretty versatile. You can change the bevel of the chamfer. You can change the height of that chamfer. And then obviously you can change the whole height of the baluster itself. So we're trying to make things as flexible as possible with the shape being the defining factor. So to go back, this is a different rail structure as opposed to the ones that we saw before that were, it's just got the top and the bottom rail. This one is a ton of rails and with a singular baluster. So here we started naming these like slat 1, 2, 3, 4, 5, 6. Actually, there's not a slat 5. But then I'm setting the height at, 5.5 inches is the 1x6 trim that we're using, 2x6 trim, excuse me. And then I'm spacing that and counting 5.5 plus 5.5 plus the gap. So you're kind of seeing there's the 5.5 plus the 5.5, and then there's a gap number right there that's pushing it up. And this offset is interesting because that's allowing us to justify where it's sitting within the plane of the rail. So you can tell here that there's the rails are sitting towards the face of the deck, the vertical face, and then we've got a 4x4 as a baluster sitting in the back. So they're kind of justifying where they all sit. So that way, when we cut a section, I can see exactly how it's supposed to be built. And all you have to do is throw some detail items in, and Bob's your uncle. So it's pretty great because this is all I'm doing is drawing. I'm drawing a line, and then it's creating all those rails for me at once. And so, too, you can see there's that top rail, which is a rotated 2x6, and then we have the other ones that are vertical 2x6s, and we've got that one 2x2 right here. So again, all I'm doing is drawing a line from point A to point B, setting this as the railing, and it's as simple as that. So adding handrails, this is getting a little bit more complex to where like we just created a rail, but now we want to add a handrail to the guardrail. So within this, you can see there is the handrail option 1 and the handrail option 2. It kind of jumps out of the view when I click on it, but you can pick what your handrail is. And so you're able to say, like, right now it's a stainless steel handrail. I can change it to the rectangle and hit apply, and then it shifts it back to that. And so within the handrail itself, you can then come over here, and that there is your extension style. So this is the 1 foot extension. And do we want it to be 1 foot in line, or do we want it to be 1 foot level? Extension, as we get to the bottom of the handrail, what kind of supports do we have on that handrail? Do we have like wall mounted, or is it going to be a different shape than we want? You know, you can look at the office and see that there's a bunch of different ways that we can attack the wall mount for the handrail. And then you can also set the material and how you do the transitions from whether they're welded or if they like have a gooseneck or all that. So there's a bunch of varieties of how you can set this up, and it's kind of nested within nested within nested, which is why they're pretty complex. The other thing too to notice is that there's a hand clearance. So it's already telling you that there's a 4-inch gap from the wall to the rail. So when you draw the wall, the railing, you're going to draw it along the wall, and then that's automatically going to have a 4-inch offset to give you the hand clearance for your hand. So again, you're not having to do all out math. You're just saying the wall is on the rail or the rail is on the wall, and then it automatically offsets it for you. So that's how you set up the, like, if you have the guardrail, you add a handrail, you give it the handrail, the hand spacing, and you pick the profile that you want it to be, and it's once you understand it, it becomes simple. Okay, when we talk about end posts, sometimes when we're drawing things, we're not actually seeing that the end, like the rail can go to the very end, and that we want to pull that back. So I say that this is a 2x6 chamfer, or a 6x6 chamfer column baluster, and we want, if it's 5.5 inches, half of that is 2 3/4. So when I drew this baluster, the center of it is in the center of the object. And so what I really want is, if this was going from baluster end post to baluster end post, I would actually be cutting off half of the baluster. So that's why I'm purposely pushing it 2 3/4 inch over on one side and the 2 3/4 inches on the other side, to bring it in to justify the whole end post to end post is the line. So again, this is where the math comes in, where it's like a lot of it is you're halving the value to then understand, because the things are built off of the center of the baluster. So a lot of railings is what's the half of that value, and then I need to half it again, and then I need to half it again to understand how it sits symmetrically within each thing. And so again, when we've been talking about individual balusters or pickets and rails, there are certain situations where we want a look that is not achievable by a single baluster repeated in a certain way. And so this was a railing that we did for Ingram for the Montevallo Mountain Brook condos, and it's a chevron slats with the vertical pickets above that mid rail. So these are set up as panels, which are another thing. Like if you've done glass panel railings and stuff like that, where it's like every so often there's a baluster, but the most of it of the railing is a panel, and so this is a lot more complex because it's dealing with the overall length of the rail, and then I'm wanting to half that, and that's where the mid baluster sits, and then I also have the panels within that that are justified. But this allows us to have that middle pyramid cap right in the middle, and then I'm figuring out the dimensions for the panels to make sure that those fit. And to Keaton, to your point, this is where like I have a left and a right here. So I have a left chevron, like a vertical diagonal up, and then I have a diagonal down. Um, and those are just, I set those up with pre-baked fill patterns to have those lines. And then I can just change it to be like, these are this way, or if I wanted to rotate them and I can send them outward and we could go that path. So again, it's allowing us to iterate really quickly without having to spend a bunch of time individually drawing railings or changing railings and stuff like that. Any questions? Right. Um, the baluster family is it's an own individual RFA, so you'd set up it as a family. It has a base level, and then we can then start defining higher levels to go up. So the the chamfered column or the chamfered baluster, I keep calling it that. The chamfered baluster has a baluster height set, and then it has the top extension, and then I have a bevel angle. So I can then change the bevel angle, I can change the extension, I can change the entire height, and that's all based upon the design architect's direction. So trying to build these to where, hey, if it can change and they want it to change, let's build it to where it can do that without us having to make 5 or 6 different families, and then we're having to constantly change it out. You're just having to be like, oh, let me just change a value and then let's see how that looks. The pyramid cap, this one's interesting because this was based off of the pyramid cap baluster wanting to have the extension below the um, the floor and then below the deck, and then it comes to a point, and this was really a sculptural railing in a specific location. And so we added a few things in here, whether it's the baluster cap height that essentially elongates that pyramid. I can make that taller or shorter. And then I have a floor depth constraint, which allows me to extend the baluster past the floor. And then that I have a bottom extension check mark, which then allows me to turn that the pyramid cap on the bottom on for that location. So I can use this family for both a pyramid cap and with the extension, and it's the same family. I can just toggle 1 or 2 off. So um, again, it's pretty versatile. It's really just limited by our minds of what we can create, and then you can go from there. And I believe, yeah, that's the end. So does anyone have any questions? All right. So I'll see y'all at 10 o'clock.
All right. Thank you.
Thanks, Kurt.
Yep.
Thanks, Kurt.
The claps.